For a lot of people, the image of a beam pumping unit is what comes to mind when they think of oil production. I remember driving with my parents on vacation through the southwest area of the country and seeing literally hundreds of them bobbing up and down in the fields. Now, I didn't know as a kid just why they existed or how they worked. I just know what my dad told me. They pump oil, son. Anyway, beam pumping units are used when the natural pressure of an oil reservoir falls below the point at which it comes to the surface on its own. Beam pumping units use sucker rod pumps downhole to get the oil out, in one of the oldest and most commonly used processes found in the petroleum industry. This is the first section of a three-section module on beam pumping unit principles. In this section, we will look briefly at the basic operation of the sucker rod pumping system and at the major parts of the beam pumping unit. Now, a sucker rod pumping system consists of four main components: a beam unit, a power unit, a sucker rod string, and a subsurface pump, sometimes called a sucker rod pump, located downhole. The surface power unit provides the energy necessary for pumping the well. Another part of the surface equipment, the beam pumping unit, transfers this energy from the power unit to the sucker rod string, which transmits the energy from the beam pumping unit to the subsurface pump. The function of the sucker rod pump is to lift fluid to the surface. This is accomplished by the up and down movement of the sucker rod string. The top piece of the sucker rod string is referred to as the polished rod, and is just that, a polished rod. The polished rod goes through the stuffing box, which is designed to create a seal around the polished rod as it moves in an up and down motion. The remainder of the rod string, including the pump itself, hangs off the polished rod. As the rod string and pump move downward on the downstroke, the pump captures a quantity of fluid. As the rod moves upward on what is known as the upstroke, the trapped fluid is lifted to the surface through the tubing string. Very simply, that's the operation of a sucker rod pumping system. For this module, however, we'll be looking more closely at the surface power unit and the beam pumping unit. We will cover the sucker rod string and sucker rod pump in more detail in a later module. Now, the main component of a beam pumping unit is a heavy steel beam that is balanced on a pivot, much like a seesaw. The force on one end of the beam is a string of sucker rods plus the weight of the well fluids. The other end of the beam is driven by the surface power unit. This power unit supplies energy in the form of rotary motion. However, this rotary or circular motion isn't useful until it is changed to the reciprocating or up and down motion needed to operate the pumping system. The crank mechanism creates this change. Linkage arms connect the crankshaft to the beam. One end of each arm, called a pitman arm, is connected to the crankshaft at some point away from the center of the rotation. The other end of each arm is connected to a point on the beam. As the crankshaft rotates, the lower end of the pitman arms moves upward around a circle, lifting the end of the beam. At the top of the circle, the end of the beam will be at its highest points, or top dead center, TDC for short. As the crankshaft continues to rotate, the arms begin to fall, pulling the beam end downward to bottom dead center, or BDC. Power from the power unit rotates the crankshaft. One complete rotation of the crankshaft is called a stroke. When the beam moves the sucker rod upward, it's called an upstroke. And when the sucker rod is moved downward, the movement is called a downstroke. So, as the crankshaft rotates, the beam seesaws up and down. Okay, let's look at what the beam pumping unit is doing. On the upstroke, the beam lifts, in essence, two different quantities of weight: the weight of the sucker rods and the weight of the fluid being pumped up and out. On the downstroke, the only weight on the beam is the weight of the sucker rod string itself. These pieces of information, the weight of the sucker rod string and the weight of the fluid being removed, are important to consider when a pumping unit is sized for an application. To counterbalance the weight of the sucker rod string, we use a counterbalancing system, in this case a physical weight, that is somewhat less than the weight of the sucker rod string. A power unit is sized to deal with the remaining weight, that of the fluid being pumped up and out on the upstroke. Now that we've talked about the basic operation and theory behind a beam pumping unit, let's look at its components. The steel or concrete platform on which the surface equipment is installed is known as the foundation. This platform must be heavy enough to keep the beam pumping unit from tipping over, and rigid enough to withstand the forces applied by the pumping action. Also, the main structural element of the beam pumping unit, the base, this black I-beam, is attached to the foundation. The base joins the power unit and beam support members and keeps them in alignment. Overhead is the beam itself, which is attached to the base by the Samson post. At the end of the beam is a hanger assembly, while at the other end is a counterbalancing mechanism. Now, at this end of the unit, we have the crankshaft assembly, the gearbox, and the power unit. Well, I think that's about enough for this section. In it, you've gotten a chance to see the basic operation of a sucker rod pumping system. And we've talked about the theory behind the operation of a beam pumping unit, as well as taken a quick look at its components. So take some time now to read over this section in your manual. Look at this section on the tape again if you want to, and when you're ready, answer the questions at the end of the section. In our next section, we're going to look more closely at each of the components in a beam pumping unit. See you when you're ready. Beam pumping units can be identified by the location of the beam support structure and the type of counterbalancing used. Now, the most common type is called a conventional unit, like this one. But two other types are also used. These are the front-loaded and air-balanced. In a moment, we'll take a look at the differences between these. This is the second section of a three-section module on beam pumping unit principles. In this section, we will look at the details of the beam pumping units and their different designs. The beam, which is sometimes called a walking beam, is the primary and most visible part of the beam pumping unit. It transmits energy from the power unit to the sucker rod string. The beam must also have enough strength to withstand heavy loads without bending or breaking. Supporting the beam is a structure called a Samson post. This post is usually made with 3 or 4 legs of I-beam steel. A saddle bearing bolted to the top of the Samson post provides support for the beam and allows it to pivot easily. The most common saddle bearing is a bronze bushing type, although tapered or spherical roller bearings are also used. Because the saddle bearing carries such a heavy load, it is lubricated with grease instead of oil. At the end of the beam is an arc-shaped piece called the horse head. The horse head keeps the hanger assembly positioned over the well. As the beam moves up and down, the horse head moves in a curved path. The hanger assembly connects the horse head to the sucker rod string and is made up of the bridle, carrier bar, and clamp. The bridle, or wireline hanger, is a flexible steel cable loop and is fastened at the bottom of the loop to the carrier bar. The bridle is attached to the horse head by a wireline equalizer sheave on the curved face of the horse head, and is kept hanging vertically by the weight of the sucker rod string. As the horse head moves in its curved path, the bridle keeps the carrier bar moving in a straight vertical line directly over the wellhead. A clamp is bolted around the top of the first rod in the string, commonly called the polished rod, and holds the rest of the sucker rod string. The clamp rests on and is supported by the carrier bar. At the opposite end from the hanger assembly are the counterweights. On conventionally counterbalanced beam pumping units, the pitman arms are attached to the beam at one end, while the horse head is on the other, with the Samson post in between, like this one. The crankshaft assembly transmits power to the beam. This assembly converts the rotary motion of the crankshaft to the reciprocating motion of the beam. The crankshaft assembly consists of a crankshaft, crank arms, pitman arms, wrist pins, equalizer, and equalizer bearing, or tail bearing. Two crank arms are attached to the ends of the crankshaft. There are usually several holes along the crank arms to provide for different stroke lengths. The lower ends of the pitman arms are connected to the crank arms by means of wrist pins placed in pre-drilled holes. The wrist pins act as bearings around which the bottom of the pitman arms rotate. The upper ends of the pitman arms are connected to an equalizer. The equalizer is connected to the beam through an equalizer bearing. On conventional beam pumping units, two types of counterweight assemblies are used: crank weights and beam weights. The crank counterweights move downward on the upstroke and move upward on the downstroke. On the upstroke, the falling weight of the counterweights helps lift the sucker rod string. As the counterweights swing around and move upward on the downstroke, the weight of the falling sucker rod string can supply enough turning force to lift the counterweights. Crank counterweights can be mounted closer to the crankshaft or farther out on the crank arms. By moving the counterweights away from the crankshaft, you increase the amount of balancing force. When crank counterweights are not appropriate, beam weights are sometimes used. Beam weights are placed directly on the beam, on the end opposite of the horse head. Now, they are used only on smaller beam pumping units. With these weights, the size of the weight and its distance from the Samson post determine the amount of counterbalancing effect. There are other kinds of beam pumping units, referred to as non-conventionally counterbalanced beam pumping units. On these units, the pitman arms are connected to the walking beam near the horse head. The Samson post is located at the end of the walking beam instead of in the center. Now, two of these non-conventional units are the front-loaded beam pumping unit, like this one here, and an air-balanced beam pumping unit. On a front-loaded beam pumping unit, the pitman arms pull the horse head end of the beam down when the crank arm is moving downward. The design of the crank arms causes the rod string to speed up on the downstroke and slow down on the upstroke. Crankshaft weights are normally used for counterbalancing on front-loaded units. A set of crank arms are mounted on the crankshaft. Pitman arms are connected to one end of the crank arms, and the counterweights are mounted on the other end. These two ends are set about 190 degrees apart. Front-loaded beam pumping units tend to reduce the loading on the polished rod. Their action also creates a better fill of the sucker rod pump during the downstroke, and thus increases overall production capacity. The air-balanced beam pumping unit is pivoted similarly to the front-loaded unit, in that the Samson post is located at the end of the beam, the walking beam, opposite of the horse head. However, instead of weights mounted on the beam or attached to the crankshaft, a cylinder filled with compressed air is attached to the beam near the horse head. The cylinder moves up and down over a stationary piston mounted to the base. As the rod string is lowered, the cylinder is pushed down over the piston, compressing the air inside the cylinder. When the beam begins to move upward, this compressed air helps to lift the sucker rod string and the well fluids. Almost all pumping units have a gearbox. Most beam pumping units use double reduction gear trains mounted in a closed box. Two sealed shafts extend out from the gearbox. One has the sheave mounted on it. The other shaft is the crankshaft. The gearbox decreases the speed and increases the torque or turning force transmitted to the crankshaft. The smallest gear is mounted on the sheave shaft. Speed reduction occurs between this gear and the larger gear mounted on an intermediate internal shaft. Further reduction occurs between the smaller gear mounted on the same intermediate shaft and the larger gear mounted on the next intermediate shaft, and so on. The final gear in the drivetrain is mounted on the crankshaft. The gears are lubricated by oil splashed up from the bottom of the box. A brake mechanism is mounted on the outside of the gearbox. This is used to stop the beam at any point in its cycle for either maintenance or adjustment. Well, this concludes the second section of our module. In this section, we looked at each of the components of the beam pumping unit in greater detail. We also discussed the major types of pumping units. So once again, take some time to read this section in your manual. Look at the tape again if needed, and then answer the questions at the end of this section. In our last section, we're going to look at the power unit and lubrication. Again, I'll see you when you return. In order for the beam pumping unit to function effectively, it must have a reliable source of power. In this final section, we'll look at the various power units used in the industry. Furthermore, to operate efficiently, both the power unit and the beam pumping unit must be kept properly lubricated. This is the third section of a three-section module on beam pumping unit principles. In this section, we will look at power units and proper beam pumping unit lubrication. Two types of power units are used today as prime movers for beam pumping units. Depending upon the requirements of the specific well, either electric motors or internal combustion engines can be used. Electric motors are popular as prime movers for various reasons. They can be set to automatically start and shut off. They usually run at 1200 RPM. They are available in a variety of sizes to match specific pumping needs. Electric motors have a lower initial cost and lower maintenance requirements, and they're built for all-weather service. Two-cycle internal combustion engines were among the earliest engines used to power beam pumping units because they could use casing head gas or natural gas for fuel. Another advantage was the flexibility of speed control. Internal combustion engines are run near the upper end of their speed ranges to maintain a smoother output. Multi-cylinder engines, similar to automobile engines, are also used as prime movers. They operate at much higher speeds, but do not have the same smooth speed control as two- or four-cycle engines. The power produced by the power source must be transmitted from the source to the gearbox. This is accomplished by using belts. One or more belts move around sheaves or pulleys mounted on the prime mover and gearbox shafts. Since the speed of the prime mover is much faster than is needed to move the sucker rod string up and down, speed reduction is necessary. Different sized sheaves reduce the speed of the prime mover. The smaller sheave is mounted on the prime mover, and the larger sheave is mounted on the gearbox shaft. Depending on the particular ratio of sizes, the smaller sheave will make about 20 rotations for each rotation of the larger. V-belts are used because they have a greater contact area than flat belts. The friction developed by this greater contact area provides better power transmission from sheave to sheave. But to maintain this efficiently, the belt must be adjusted to its proper tension. Also, for safety, the belts and sheaves should always be covered by a guard. If the guard is removed, the moving belt and sheaves can cause serious injury. Finally, efficient operation of the beam pumping units relies upon proper lubrication of the critical moving parts. The saddle bearing and equalizer bearing carry the heaviest part of the load and usually have to be lubricated with bearing grease. The gears in the gearbox are lubricated by oil splashed from the bottom of the box. However, care must be taken to keep water out of the oil so that the gears don't corrode. The wrist pin bearings come with sealed grease reservoirs and easy access grease fittings. Also, internal combustion engines used as prime movers require the same type of lubrication as any other internal combustion engine. And that ends this section on power units and lubrication. In it, we saw the two primary types of power sources for beam pumping units. We also looked at some of the key operating points requiring lubrication. This also concludes this module on beam pumping unit principles. In our module, we've looked at the basic operation of a sucker rod pumping system, of which the beam pumping unit is a part. We discussed the various components of a beam pumping unit and how they operate together, and we looked at different types of beam pumping units in use today. All right, take some time now to read this last section in your manual. Look at the tape again if necessary, and finally, answer the questions at the end of the section. Beam pumping units have been an important part of the petroleum industry from the beginning, and with proper operation and maintenance, they can continue to play an important role far into the future.